Welcome back. Today we will be looking at the topic laws of indices. Now in this video we will be introduced to all 6 laws of indices. However, we will only focus on 3. The part 2 of this video is where we will look at the remaining 3 laws of indices. The laws of indices enables expression involving powers to be manipulated more efficiently. An index, which is the singular term for indices, is the small floating number that appears after a number or letter. Now, what do we make reference to when we speak of the small floating number? Our 2 here is what signifies that. It is made reference to as our index, exponent, or power. The number that it floats above is made reference to as our base, and it is represented by this 3 here. The base is what tells us what is to be multiplied, whilst our power is what tells us how many times we are to multiply our base. These are 2 examples. b risen to the 4th power, written in its expanded form, is b being multiplied by itself 4 times. Because our base says what is to be multiplied and the power says how many times we are to multiply it. This is saying we are going to multiply b by itself 4 times. Similar to our second example, 5 cubed. 5 is being risen to the 3rd power. Therefore, this is saying 5 should be multiplied by itself 3 times. As aforementioned, there are 6 laws of indices, and they goes as follow: the multiplication law, the division law, the brackets law, the negative power law, the power of 0 law, and the fractional powers law. The first law is our multiplication law. This states that if the 2 terms have the same base and are to be multiplied together, their indices are added. Now in this example below, we have 2 terms. The first term is a risen to the power of n, and the second term is a risen to the power of m. They are being multiplied together, therefore the multiplication law can be in effect. Now, the law states that if we have the same base, we will place back that base for our answer, and the sum of the indices will be our new power. It is represented here. The bases were a, and so for our answer the base is still a, and the powers were n and m, and you see for our answer we have n being added to m. Let us look at an additional example. This question reads 2 cubed multiplied by 2 to the 1st power. This being written in its expanded form is 2 being multiplied by itself 3 times, representing this first term. We place back our multiplication sign, and for our second term the representation is 2, because 2 risen to the 1st power is just 2. Now, in order to get our answer, we know that if the bases are the same, we place that same base again, and we will just count how many 2s are there, and that will be our new power. Now, after counting 1, 2, 3, 4 2s, we know that our new power is 2. For our second example, the question reads x cubed multiplied by x to the 1st power. This is an alternative method on how to work the multiplication law. We know that our bases are the same, and so we place it back. Our base is x, and so we place back the x here. Now it says that when the base is the same, we add the power. The first power was 3 and the second power was 1. When we add 3 and 1, our new power is the sum of them, which is 4. So x risen to the 4th power is our answer. Now to look at law number 2, the division law. This law states that if the 2 terms have the same base and are to be divided, their indices are subtracted. Here is an example below. 5 risen to the power of 8 is being divided to 5 squared. Now, since the bases are the same, we will place back that same base and we will subtract the power according to the division law. If we have 8 and we subtract 2 from it, our answer or difference of 8 and 2 is 6. That is what we see happening here. Now, it is basically a similar concept to the multiplication law. However, when we are multiplying, the powers are added, and when we are dividing, the powers are subtracted. So you can use that on how to remember it. The additional example for this is x risen to the 5th power divided by x cubed. Now, if this is to be done in the first method that I explained, which is the expanded form, we would realize that for our numerator, we will have x being multiplied by itself 5 times as a representation for this, and for a denominator we have x being multiplied by itself 3 times, which is a representation for this. Now, if that is further simplified, we are going to cancel in the process of division, which is canceling what is in our denominator to what is in our numerator. X divided by x goes 1 time, x divided by x goes 1 time, and finally this x divided by this x goes 1 time. We realize that there is nothing left in our denominator, however we still have something left in our numerator. We want to rewrite this back in exponential form. In order to do that, we are just going to focus on what is left. What is left in our numerator are 2 x's. If this is to be written back in exponential form, we would know that our base is what is being multiplied, which is x, and so we'll place that back. And for power, we know that x is being multiplied by itself twice here, and so we know that our power would be 2. For the denominator, we would have cancelled everything, and our new denominator value would be 1. 1 being divided into x squared is just x squared. For the second example, which is x risen to the 5th power divided by x cubed, which is the same question, however it's done in the alternative method, is just realizing that our bases are the same, placing back that same base x, recognizing our power. The first power is 5, the second power is 3. 5, and we subtract 3 from it, our new power is going to be 2. The difference of 5 and 3 is 2. X squared is our answer. You realize that the same question, same answer, however the procedure was different. Whichever procedure works better for you or is simpler for you, utilize that one. We are going to move on to law number 3. This is our bracket law. The bracket law states that if a term with a power itself is raised to a power or index, then the powers are multiplied together. Let me explain further. In this general example, we realize that if we have a base risen to a power and then that term is then bracketed and risen to another power, then the bracket law states that we are to place back that same base and multiply both powers. Let me give some additional example again. For the first example, we would realize that our base is y, and our power is -4. Y risen to the -4th power is bracketed and then it is risen to another power 6. The bracket law states that we are to multiply powers when we have a variable risen by 2 power. Placing back our base y here and multiplying the -4 by the 6, the product of -4 and 6 is -24. So our answer is the same base and the product of the powers that we would have had to begin with. For the second example, it is a bit different because in this example, like never before, we have a coefficient. The coefficient is 4. Now, when we have a coefficient, it is not to be neglected. What is required of us is that we are going to raise both the coefficient by the power on the outside, as well as we're going to allow it to still be risen above the variable. So after it's separated, we have the coefficient and we have the variable standing on its own. The coefficient is risen to the power on the outside, which was 3, and the variable risen to the power of 7 is still risen to the power on the outside, which is 3. So we have 4 cube, x risen to the 7th power cube. After this is simplified, we are going to simplify the first part, which is the coefficient risen to its power, which is 4 cube. 4 cube simplified is 64. X risen to the power of 7 cube is x to the 21st power, because we utilize the bracket law. The bracket law states that whenever we have two powers, we multiply them. The product of 7 and 3 is 21. So when we simplify 4 cube, we get 64. 7 risen to the power of 7. Risen to the power of 7 times 3 is x risen to the 21st power. Now that is the end of this video. If it was helpful to you, please comment down below on what else I can explain or that you'd like me to explain. Remember to like, share, and subscribe. See you in the next class.